Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Zuan bin Muhammad Nurham. My number is 33 TPE 19F10183. Okay, today I want to present about the heat exchanger for the working principle. How does a heat exchanger works? Heat exchanger metals shell and tube work by transferring heat from one place to another. When a furnace burns natural gas or propane fuel is exhaust or combustion byproduct, also known as flue gas, enter and travel through the heat exchanger. The hot flue gas hit the metal as the gas make its way to the exhaust outlet of the furnace. As this is happening, the hot metal hit the air, circulating over the exterior of the heat exchanger. Okay, primary heat exchanger. This part contains the hot flue gas found closest to the burner in a furnace. As a result, the flame and heat subject it to the most stress, which can cause cracking and heat stress. Over time, furnace that 70 to 80% efficient have one heat exchanger. Secondary heat exchanger. If you have a furnace that is considered high efficient, 19% plus efficient, if contain both a primary and secondary heat exchanger. As the combustion exhaust leave the primary heat exchanger, it travel into a secondary heat exchanger where more heat is released from flue gas, and water vapor begin to form. This chain of state from water as vapor to a liquid release latent heat in the secondary heat exchanger, bringing the furnace to an even higher level of efficiency. This is why high efficiency furnace are sometimes referred to as condensing furnace. Secondary heat exchanger are generally constructed from stainless steel or a coated steel material capable of withstanding heat, moisture and acid. Okay, 2. LMTD definition. Law means temperature different. Okay, law means temperature different. LMTD is an indicator of the average temperature difference between the hot and cool fluid in a heat exchanger. Is calculate using the following equation. LMTD Okay, LMTD sama dengan T1 minus T2 bahagi in kurungan sama dengan T1 bagi T2. Okay, nak cakap T1, the temperature difference between hot and cool fluid at one end of the heat exchanger. T2, the temperature difference between hot and cool fluid at the other end of the heat exchanger. As can be seen from the equation, LMTD use the log means of the temperature difference instead of a arithmetic means. Number of transfer unit NTU. Effectiveness relation of the heat exchanger typically involve a dimensionless group called the number of transfer unit NTU. NTU sama dengan UAS bahagi C min sama dengan UAS sama dengan bahagi M flow CP tutup kurungan means for specific volume of U and C min The volume of NTU is a measure of the head transfer surface area AS. The NTU, the heat exchanger is also convenient to define a capacity ratio C. C sama dengan C min bahagi C max. The effectiveness of a heat exchanger is a function of the number of transfer unit NTU and the capacity ratio C. Okay, for the second task, working principle of shell, I choose the soalan nombor 2, iaitu shell and tube heat exchanger. For the task 2, working principle, the working of a shell and tube heat exchanger is fairly simple. One fluid flow inside the tube and the other through the shell while flowing. They exchange the heat, which means the cool fluid gain the heat from the hot fluid. So one cool fluid enter the shell or tube side or channel side inlet nozzle and come out of the outlet nozzle as hot fluid. Obviously, the other fluid will become cool in the outlet. Then in the inlet, the fluid flow inside the shell and tube heat exchanger can be parallel flow or cross flow. Okay, for 2, construction basic and component of shell and tube heat exchanger. Okay, although the exist a wide range of design and materials, some components are common in all shell and tube design. Shell and tube heat exchanger represent the most widely used vehicle for heat transfer in process application. They frequently are selected for duties such as process liquid or gas cooling, process or refrigerant, vapor or steam condensing, process liquid, steam or refrigerant evaporation, process heat removal and preheating and feed water, thermal energy conservation effort and heat recovery. Although there exist a wide range of design and materials, some components are common to all shell and tube heat exchanger. That the tube are mechanically attached to tube sheet, which are contained inside a shell, which port for inlet and outlet fluid or gas. They are designed to prevent the liquid flowing inside the tube from mixing with the fluid outside the tube. Tube sheet can be fit to the shell or lowered to expand and contract with thermal stress. In the latter design, an inspection below is used, or one tube sheet is allowed to flow inside the shell. The novice tube sheet approach allow the entire tube bundle assembly to be pulled from the shell to allow cleaning of the cell circuit. Fluid stream allocation. There are number of practical guidelines that it follow can lead to the optimum design of a gift-heated heat exchanger. Remembering that the heat exchanger primary responsibility is to perform its thermal duty, which the lower cost yet provide in service reliability. The selection of fluid stream allocation should be of primary concern to designer. When designing, keep the following point in mind. The higher pressure fluid normally flow through the tube side, which they small diameter and nominal and thickness. The tube are better able to accept high pressure, and this approach avoid having to design more expensive large diameter component for high pressure. If it is necessary to put the higher pressure fluid stream in the shell, it should be placed in a small diameter long shell. all other items be equal place. Corrosive fluid in the tube is it's much less expensive to use the specially alloy designed to resist corrosion for the tube than for the shell. Other tube side component can be clad with corrosion resistant material or epoxy coated. Flow higher falling fluid through the the tube are easier to clean using common mechanical method that the shell. Many possible design configuration affecting tube pitch, buffer use and spacing and multi-nozzle, to name a few, can be used when laying out the shell circuit. Because of this, it's best to place fluid requiring low pressure drop in the shell circuit. The fluid with the lower heat transfer coefficient normally goes in the shell circuit. With this setup, loafing turbine, which will increase available surface area, can be used to offset the low heat transfer rate. Tube heat exchanger with diameter of 10 to more than 100 typically manufactured to the standard set for by the tubular exchanger manufacturer association. Generally the 0.6 to 5 to 1.5 turbine used in the Tema size exchanger is made from low carbon steel, copper, admiralty, copper, nickel, stainless steel, alloy, inconel, titanium, or other materials. Tube are either draw a seamless or with the high quality electros resistant weather tube as hybrid good grain structure at the word and through tube with low fin and interior leafling is specific for certain application. Surface enhancement are used to increase the available metal surface or aid in turbulence. There be increase the effective heat transfer rate. Fine turbine is recommended when the shell side fluid has a substantially lower heat transfer coefficient than the tube side fluid. Fin turbine is not fin in its landing areas where it contains the tube sheet. Also, the outside diameter of fin portion of tube design is slightly smaller than the unfit area. This feature allows the tube to be slid easily through the buffer and tube support during assembly while still minimizing fluid bypass. Okay, tube sheet. Tube sheet usually are made from a round flat piece of metal hot drill for the tube and a precise location and pattern relative to one another. Tube sheet manufactured from the same range of material as tube. Tube are attached to the tube sheet by pneumatic or hydraulic pressure or by roller expansion if needed. Tube hole can be drilled and removed or they can be machined with one or more grooves. This greatly increase tube joint strength. Okay, shell assembly. The shell is constructed either from pipe up to 24 or roll and with the plate metal. For reason of economy, low carbon steel is in common as but other materials suitable for extreme temperature or corrosion resistant of the specific using commonly available shell pipe to 24 result in reduced cost and ease or manufacturing partly because they generally are more perfectly rounded roll and will the shell. Roundness and consistent shell inner diameter are necessary to minimize the space between the buffer outside edge and the shell as and safe space allow fluid bypass and reduce performance. Okay, end channel and bonnet used to control the flow of the tube fluid in the tube circle and channel or bonnet typical are fabricate or cast. They are attached to the tube sheet by bolting with a gasket between the two metal surface. In some cases, effective sealing can be obtained by installing an O-ring in machine groove in the tube sheet. Okay, buffer. Buffers serve two important function. First, they support the tube during assembly and operation and help prevent vibration from flow in this. Second, they direct the shell side fluid back and forth across the tube bundle to provide effective velocity and heat transfer rate. Okay, and number 3, shell and tube for the advantage or disadvantage. Okay, for the advantage, first, less efficiency and compared to plate type colors can be used in system with higher operating temperature and pressure. Pressure drop across a tube collar is less. Tube leads are easily located and plug since pressure test is comparative easy. Tubular cooler is refrigeration system can act as reserve also using subscript seal and it protects the whole cooling system against corrosion. Tube cooler may be preferred for lubricating or cooling because the pressure different. For the disadvantage for the shell and tube head exchanger, transfer efficient is less compared to plate type color. Cleaning and maintenance is difficult since a tube cooler requiring enough clearance at one end to remove that tubeness. Capacity of tube cooler cannot be increased, require more space in comparison to plate cooler. Okay, for the reference I search at Google. I use the Google for reference. Okay, thank you.